the cloud. Excellent.
Awesome. Thank you.
You bet. Have fun. I'll come back in 45 minutes or an hour or so and see how things are doing.
Okay,
All right.
awesome.
Bye.
So I guess we can get started whenever we want, or we can wait a few more minutes. Looks like people are still joining. I guess we can wait until 5 after. Is everyone ready to discuss redfish?
Yes.
Okay. So I haven't really had time to prepare much, but I was able to pull up our interoperability profile for Ironic, and I also pulled up what Boris had posted as lifecycle suggestions, which includes curl commands against resources. And I think we should probably kind of talk about what we do, and we can talk about the proposed endpoints, if that makes sense. Does that work for everyone?
Yes.
Okay, excellent. Well, then in that case, I will share my screen just to make this easier and share a link. So as was in the Slack chat, the request was to kind of, and also from me last week, was to kind of provide an overview of what Ironic does in order to put a machine into a state where we can start provisioning an operating system. And Ironic does this via Redfish or IPMI, but we'll focus and talk about Redfish. With that in mind, the folks at Dell were kind enough to create an interoperability profile a couple of years back to kind of help convey the minimum required endpoints that we have. And I will kind of walk through this and reveal that most of it's not actually required, which should be no shocking surprise to anyone. From there, I'll open up the lifecycle markdown and we'll kind of walk through that. Sound good? Any questions, concerns?
Are you sharing your screen?
Not yet.
Not yet. Okay.
Actually, I do not have. Oh, yes, I do have rights to share my screen. Let's see. Bear with me for a moment here. I think this is the right screen. I want to share. Okay. Hopefully
Excellent.
you see an interoperability profile, which is a bunch of JSON.
Yep.
Okay, perfect. So primarily, there's the primary resource that we interact with is the boot resource on the system in Redfish as the first phase of interaction. And we tend to use a boot source override enabled, which is this first value. And then we there is a boot source override mode in Redfish. You'd be surprised the number of people that want to run things in legacy BIOS mode that are physical hardware out there. I would recommend that if we can just keep UEFI, since most of this hardware only supports UEFI, or at least that runs an operating system, I should say, would be a good way to frame it. And then generally what we also do is we set an override target, say where to boot the machine from. And that target typically is PXE. And the order of operations is basically we change the boot mode and boot target. We reboot the machine or power the machine on via the power endpoint. I am drawing a blank where in the schema it is for Redfish off the top of my head. And I'm actually wondering if it's even missing from this. Anyway, so we power the machine on. And we typically expect things to network boot. Virtual media-based deployments is a very popular thing these days that we're seeing many operators try and use because you can, it doesn't necessarily require DHCP or other network resources to have it working. So it's a much more simpler way. If you can talk to the BMC, you can inject an image, you're in much better shape. There is growing interest for booting from a UEFI URL. Say you have an ISO image on a remote target and say boot from it as HTTP boot. We don't support that today. There's a lot of discussion about doing that and interest. It's just something we don't do today. And actually the schema is very similar. There's just another value that would be under the boot property. I would just say it's like HTTP boot URI is the actual text string. But generally, once we have confirmed that we have deployed an operating system through PXE, we tend to actually set the machine back to boot from hard disk. And we power cycle the machine again. That is the path that we use. There are some variations to this path. It's not the path everyone uses, but it is the simplest path we have found using some of the original endpoints from Redfish. I will note that there's some history with the DMTF where they tried to change the behavior boot source override enabled and promptly fixed the change. It was actually they meant one thing in the documentation, and then a bunch of implementers interpreted it as, oh, we did the very wrong thing. And they actually all made breaking changes to their Redfish implementations, which was so fun for about a year. Luckily, that's not a thing anymore. So that at a high level is what we do. We don't issue any controller resets or anything like that. It's fairly straightforward. But from a mechanics, it should be able to see the markdown force posted.
Yeah.
Okay. So we basically do this. We issue a power cycle. We don't reset the manager. Because resetting the manager is, as I understand, is asking the BMC to reboot. And most of these BMCs take, I think the last time I rebooted BMC took 10 minutes. And to do that as part of it.
What if you need to update the firmware of the BMC and then you must have reset? Is it part of the flow?
Not part of the actual deployment flow. If you need to do that, we expect that you do that via some other means. Like we provide specific interfaces so people can say, hey, I need to do firmware updates, or I need to ask the BMC to do this firmware update. Those tend to become scheduled tasks inside the BMC, which the BMC will then execute. And the BMC might disappear for a little bit of time while that task is running. At some point, the task will hopefully exit and the BMC will be happy. But that's not part of the actual operating system deployment. And one of the things that we found is anytime someone tries to tie a bunch of these operations together, from any, like, say, I want to deploy an operating system or do a thing to a device, and I want to start adding a bunch of additional operations that I think I should do, it tends to start getting very complicated, and you start having more edge cases that you have to handle. Like, what if the firmware on the BMC half upgrades and the machine and the BMC's half broken state, where half of the resources no longer work, and the other half is getting errors, and you might actually have to send someone to the data center to fix it. Those sorts of things. So we try to force workflows where we insulate people from trying to do everything at once. Does that make sense?
Yes.
Okay. We also don't expose the ability to reset the BMC remotely on purpose, because we don't want anyone to try denial of service attack against BMC services. That's our approach. That may not necessarily be your approach, but I would just recommend highly focused operations of what needs to happen, and not try and join multiple things together unless you absolutely have to. Kind of similar going back to the schema I was showing, the compatibility schema I was showing. We do basically, Boris is saying, set the override target, same basic concept. And one of the things that I know, even yesterday I had a conversation with someone about, well, if I can boot an operating system on the SmartNIC, I can just have that operating system do firmware updates and do other things, and you absolutely can. I think it depends on the security model of the BMC and what is supported and what's not supported. So, any questions on basic, like the path of deployment?
I have a question about the password. Are you providing a password to each BMC, assuming that you are in a data center and you have multiple BMCs? And where do you store these passwords?
So we store the passwords in a database, and we are supplied the passwords. We do not have a password setting capability by design. We used to have the ability to do that, to basically inject a password into IPMI BMCs, and actually removed it because it was a risk. We've not tried to do the same with Redfish, specifically because there has been vendor pushback on that portion of the standard, which is the host channel interface. Specifically, there was originally a standard which you basically could have temporary credentials, but you could only do so if the machine had not exited UEFI mode yet. So basically, as soon as you boot an operating system, you no longer had valid credentials to access the BMC.
So you're saying that you are setting the password using IPMI, not Redfish?
No. We don't set a password. We are supplied the password. So
Mm.
someone
There's a default password there, but if the BMCs all follow, like, one-time password change on first use, kind of like OpenBMC does, right? Then you're getting into, the first time you use it, you'd have to change it, and then you'd have to keep track of it, right?
Yeah, and that's not. We've never had anyone ask for that functionality as an open source community. We know some vendors have added logic to do basically expose the ability to change the password of the BMC, but it's not. A lot of operators set up either have a standard credential or a standard credential format they use for their BMCs, and they just roll with them and deploy to the fleet. And when they import the list of nodes they're going to work upon remotely.
I thought the state of California, or maybe a national requirement, to have no default passwords, or if they are, it's a one-time use thing.
So that might be a state of California requirement. It wouldn't surprise me. But I know you can still order hardware with default path.
I'm just, it may be difficult. Well, I'm just saying, there may be a little bit of a disconnect in the implementation of some BMCs on deep, XPUs, right? And
Absolutely. And I think if we can identify that, great. If not, if we're in a world of pain.
Yeah.
I think the thing we want to avoid, and
No, I'll let you-
well, there's this years and years and years ago. I tell the story way too often, but there was an engineer who had the very first generation of these intelligent cards at IBM, and like 2,000 compute nodes, and he was basically spending 60-hour weeks having to crack the cases to do anything with the cards, basically, and he had no quality of life. And I think that's a thing we want to avoid with these devices if we can. And if there's a way to the host channel through the host BMC, it's probably better. But I mean, that's a whole other variable. I mean, generally what we see with physical services is vendors have service tags or stickers on the devices to provide the information.
Yeah.
I do wonder if there is actual like code out there regarding one-time password setting.
Yeah, well, there's code in BMCs. I mean, I'm
Oh,
from
yeah.
Dallas, just familiar with what we do, right? But also, some of this, when I'm looking at this, it feels very like this is what we do for servers. It seems kind of server centric.
Oh, yeah.
I just wonder how far along on the journey like these NIC BMCs and XPUs are for having all these capabilities to be able to control their UEFI BIOS boot to
I'll put it this way. I personally received documentation written late last month from one of the vendors out there that has the ability to control boot order on a finite level in the BMC remotely, or in the EMC remotely, using Redfish, which means which is a capability most of the vendors don't even have, or have it in some way, shape, or form that's not standardized, which thoroughly impressed me, actually. And they were actually asking for the ability to do booting from a URL instead of virtual media, because they just don't want to have to implement the virtual media logic, because it would be more painful for them. It's a lot easier to pass a string to Eufy to say boot this than to make a device appear that Eufy can read and boot from. Does that make sense?
Yeah, because the connectivity inside an XPU may be different than a typical server. Usually in a typical server, there's almost always USB connectivity, and there's also, PCIe connectivity, because you're doing if you're doing kind of KVM access, then a lot of times the BMC is emulating a GPU, right? So, but you don't do that kind of stuff on an XPU where UART's good enough usually for like console on these things. So
Absolutely.
So the connectivity is probably a little different, like architecturally.
So this is an interesting topic because I think from my point of view, the world of virtual media makes a lot more sense to be able to say, hey, here's a virtual media device, here's an ISO. The operator already knows that the management controller can reach this URL. They're assured through their network infrastructure, because they've told the BMC, or I keep saying BMC, I'm going to say the management controller. They've told the management controller to load this URL and provide it. So you have a higher level of assurance that whatever operating system running on the device, or whatever state of that card, that it can reach that resource. Whereas if you're booting from a URL, you're actually changing the entire paradigm of access, such that the running firmware has to be able to then go, oh, I need to be able to use my card as a network device, reach out, grab the resource, and do the needful, which does change the access paradigm.
Right, so if you had separate management plane, separate user plane, and the ports were all, the high-speed ports were only connected to the user plane, then you may not have, or you have to assume that you have another, you have to assume that the NIC BMC or the AMC and the ARM complex or processors, right, are both
Mhm.
connected.
Yeah, which means that then it's either firewall rules or some point of commonality where you know there's a file that the device can reach and gain access to that you might not want a user workload ever being able to see or touch or do whatever.
Yeah, I mean, there's
That,
fixing
go ahead.
parameters like VLAN, which would be helpful, or yeah, you're not, when you say Pixie, you're not even specifying which interface you're going to use for it, right?
Yeah. Yeah. That's a really good point. That's a thing we've seen with physical servers as well. We tend to see with physical servers that there are BIOS settings where people are able to say, I want this card to operate it as my Pixie target. So they disable like the OPROM and all that functionality on, say, the first NIC, but the second NIC it's enabled and it loads and boots the machine if it's requested. That's a big question for these devices. What interface are they actually booting?
Yeah, I mean, so if you have this kind of Redfish support, I would assume that you'd also have get set BIOS attributes. But the thing is, there's no, whereas boot is more standardized in
Yes.
Redfish, BIOS is less standardized. You have to know.
No, but there is a standard from the MTF for BIOS settings. There is a BIOS attribute schema
Okay.
that is part of the
Yeah.
standard.
So does that cover what gets presented from Redfish, or does that cover something else? What am I thinking? I thought that was like SMBIOS, like the what gets presented to the OS. Because we did talk about that before.
I'm re-downloading the schema bundle right now.
Yes, let me check also.
Because
I thought,
go
I
ahead.
thought BIOS, you kind of just had like a registry where you just enumerated all the attributes that you had, but every OEM they could be different, right?
No,
Well,
but there are attributes that are common for everyone.
So the BIOS resource appears to actually be high-level interactions in the schema definition. Like I want to change the password. I want to reset the BIOS, and there's a whole OEM field under that. Actually, is the computer system BIOS? It's under computer system, isn't it?
I work with DMTF a lot, but I'm not the Redfish expert.
So I just put in the chat from the DMTF site. So you have there all the schemas in the index. And if you are going there to the BIOS, so you have there the BIOS attribute schema. This is a standard from the MTF. And you can support multiple attributes, BIOS attributes through that schema.
Yeah, but what I was saying is that there's not default attribute names, meaning like, if I had like, I don't know, virtualization or, certain, trying to think of like good BIOS attributes, but like, I don't know, watchdog timeout or something like that. That doesn't there's not a standard defined attribute that has a standard meaning, right? If I enumerate the attributes on an HP system or a Dell system, I'm going to get a different list of attributes. And I might, if I'm doing a particular operation, I might have to have a secret decoder ring that says, okay, for HP, I need to set it this way. For Dell, I need to set these attributes, right?
Yeah, that's my understanding as well.
Yes,
that
so
doesn't-
you have you can have a list of attributes, name and values, and you should enumerate them and pass them. So if you think that we should standardize the list of attributes in this form, then we can go ahead and do it. But is it something that you need?
So that's a really good question. Need versus want. Putting my hat on from having dealt with multiple server vendors over the years, generally we have like deep-rooted architectural reasons that certain values exist, and certain behavior exists deep inside of their product line. And I think we'll end up with the same sort of conundrum, I think, with DPUs, where special flag exists because of some special supported case that they have with some special customer that was one of their first customers, and they can never get rid of that option, or they think they can never get rid of that option, and that will always show up in that list. And the same constraint or architecture might have nothing to do with reality, or might have everything to do, and other vendors might go, we chose a different name, but we don't want to change it, and we've standardized on being on by default or whatever. And comparing two different hardware vendors right now, you can see a bunch of these sorts of things where it's like, by default, this option's on, but you can't actually change it on this vendor, whereas another vendor provides you the ability, but it's also off by default. And that's a very difficult thing to navigate, which is entirely separate from do the needful to get the thing up and running, unless it actually is critical. The key is setting an opinionated path for people to follow.
I have one more question about the PXE boot. As I understand that process, what you described, schema, it's implemented in the GPU, right? So once you're trying to set the PXE boot, the GPU is supposed to modify the host configuration, right?
No, not the host configuration, the configuration of its internal CPU. So that an internal firmware, so it performs the boot operation for itself.
So it means that the installation, for example, of the OS will be executed on the GPU's cores. Is that
For OS installation for the DPU's operating system, yes.
But not for the host.
Not for the host. The host would need to be a separate operation. And
Okay.
it might be that someone takes an entirely separate path for this, or not for this, for the host itself. For example, I have someone wanting to use OpenStack Ironic to deploy physical machines, and then they want to hand deploy all the DPUs in their environment. It's not ideal, but if that's what they want to do, I'm not going to say no. It's the path they feel is comfortable to them.
Okay, I see. So the support of this operation is intended for the GPU provision, right? Not for the host provision.
Correct.
Okay.
We'd have to view them as two separate operations that are completely disjointed, because if you launch one operation against, say, the DPU, you're going to have ARM binary artifacts to boot on the machine. Hold on 1 second. Cat removed from desk. You'll have to have artifacts for the processor to execute upon. And then if your host is, say, an x86-64 machine, it's going to need a completely different set of artifacts to boot the machine and have working operating system, and they're going to be completely different.
Okay.
Might be easier once all computers are ARM computers or RISC-V computers. Does that make sense? And does that answer the question?
Yes, thank you.
So for the question, we were talking about firmware settings and the need to standardize or not, and if we should. What is the opinion of the group?
Leaf, from your side, do you have anything to say here?
Well, I think, yeah, I mean, I think there's a need for just open UEFI boot targets, but so that you can specify the interface, but and then boot URL so that you can get to IPv6. I mean, it seems like there's going to be a bunch of there's going to be additional requirements. I mean, I guess you could support a minimum of PXE. Well, the other thing is, so you assume that hard drive is the normal boot flow. I guess you just override. You do a persistent override and then you clear it when you're done doing the install.
We do.
Okay. Because the installer might choose potentially like I could imagine something that might have like an eMMC and multiple partitions on an M.2 drive or whatever.
So I get where you're going, and this is a case that we have. We've kind of seen this actually. What we found is that with UEFI firmware running on machines, in the past, you used to run into cases where if you told the machine to boot from hard drive, and you changed the UEFI target internally, that it would try booting from disk. And some still do that by default, is they just ignore the UEFI target and try and take a default boot order. That being said, what we've also now noticed is if you do the UEFI NVRAM firmware update from inside that running operating system saying, here's the target I want you to boot, most hardware now honors that by default and will follow that path until they're told otherwise. So they'll actually disregard the generalized boot to hard disk command, and they'll just rely upon the configuration in NVRAM if you update it during that window. Of course, I'm speaking of server hardware here, not DPUs. But it would be reasonable to do the same exact thing if possible.
Are you checking the boot progress via Redfish in your flow?
So we don't check the boot progress via Redfish. I guess that is now available, actually. Yeah, because we can see if the system has posted, I believe, now. That is a great question. In OpenStack, we actually run an agent that boots on site. From basically when we deploy a machine, we boot an agent unless we're told not to, and we assume that the agent is going to do the needful. that agent does phone home and tell us when we're done, which helps a lot. But we also have a bunch of different actions that we perform as part of that agent, including wiping out prior data from the machine. This is an area that it might make sense to set standards, but not actually mandate the exact mechanisms, because you may have security requirements, especially if you're moving hardware from one part of the data center to another part of the data center. If operators can clear any credentials, say, if the DPU needs credentials to log into API endpoints or message buses to provide configuration updates to the host operating system, then you generally want those credentials not to be able to be discovered by another user of the machine, if that makes sense.
Mhm. Okay, we spoke about the BMC update, which is rare. What about the DPU itself, the XPU update? Is it something that you plan to support via Redfish using the update service schema, or?
So we would expect that it would be done via updates service schema as well. That being said, and kind of towards Lee's earlier question of does everyone support all of these things? The answer is no, not everyone supports all of these things. And it'd be nice if it's supported. I know in our specific case, we have specific firmware update features that are performed by in-band operations that either need to be run on the card or run in the host operating system that connects to the card, does the needful to the card, which is not great, but it's the path that the vendor has supplied at this point in time. But if the update service is an available option, it makes a lot of sense and can be generally usable. I think the challenge might be is people may interpret the update service or have different requirements that may also need to be mapped or understood.
Okay, so I see you're saying we have two gaps. One is that the vendors will support the schemas, and then that there will be standard inside the schema of how we are using it.
Correct. Or maybe it's more if the vendors can even support that part of it with their requirements.
Mhm. What about setting secure boot options? So how it is done?
So generally that is done as a BIOS setting. One of the fields that is not standardized. And a really good example is several of the vendors do have, I think, basically a secure boot field on the Redfish targets for their overall surfers. Whereas some other vendors have it as an OEM subfield, and most tooling won't delve into the OEM fields and make those available to be changed, in large part because there's no contract there. There's no standard there, really. The vendor can have any constraints or requirements behind that we're not aware of. So that's sort of an area that we have found to be not standardized and also very problematic. That being said, those non-standardized vendors tend to be the smaller, more custom hardware shops.
Okay, and regarding resets, the XPU, so the BMC, you said from security reason you are not reset it via Redfish, but the XPU itself, do you support like reset, graceful reset, all kind of resets that?
So we do have the ability to tell a management controller to basically tell the device to reboot or to force it to reset. I think the question is delineating the XPU from any whatever workload, or when I say workload, I mean operating system running inside the XPU, and if that's what you're talking to, or if the operating system and the XPU management controller are one and the same, and what device is being interacted with. So if you're trying to reset the running workload on the card or the device itself, that's going to be separate from the actual management controller interface. Let me just go back to sharing my screen real quick, and I'll show you actually. So this is the command we use right here. And the ID is some vendors it's a serial number, some vendors it's just 0 or 1 or default string.
Mhm.
I believe the proposal for in-band access is just for there to be another system under the host management controller. The problem that you run into with trying to reset the managers also, if you have a nested relationship, there's no guarantee that the manager is the manager for the system, if that makes sense.
Yes, thank you.
A good example of that would be blade chassis may have 8 or 16 systems and 1 manager. Any further questions?
I'm sorry.
Last one. Okay,
I'm
sorry, last one from my side. How do you associate the host and the XPU, I mean, in your system?
So we, in our model, and I'm speaking for the OpenStack Ironic project specifically, whenever you enroll hardware, you're enrolling a node. And the node is something we will manage until you tell us not to manage that node. And the way we're envisioning DPUs is to be managed as a child device of a node, which is represented as another node, because they're fully fledged devices at that point. This is something that it will be in our next major release. There are some workflow constraints regarding that, but it allows kind of the disjointed approach of I can manage the machine separately from the actual DPU, because that DPU might be an untrusted, or sorry, the machine might be handed to an untrusted user who will be retrieving the machine from afterwards. And the DPU is more for the infrastructure operator on the back end to be able to provide whatever they need to do for that workload.
Thanks.
Daniel?
Well, yeah, one question. Do you think what this schema, this implementation will require additional API, which should be used by OS to get notification about the provisioning process?
I would not try. I honestly.
Because how you can synchronize, well, because like a host OS will depend on the DPU in many cases. So you should organize that process. Right?
It's a really good question. And from my point of view, I think it adds additional complexity to have that notification or that interface. But I think it also depends on your workload. So what I'm saying, where I'm suggesting is more, there's a bare minimum that should be supported to allow operators, open source projects to be able to connect to the BMC, do the needful, which may be put an operating system on or put it in a state so an operating system will deploy to it. And then after that, it's kind of outside that workflow. I mean, these operators tend to have lifecycle workflow operations that they'll work through and put an operating system on it and get it into the state required is kind of their bread and butter. They don't tend to look at the status of that individual thing. They tend to be a tool to do the needful, if that makes sense.
Okay.
I guess, go ahead.
It means in general, it should be if that interface for provisioning DPU will be used, it will be requirement for the operator to shut down host OS because there is no way to notify host OS what's going to happen. Is that correct assumption?
I think that would be a correct assumption. I'm not sure everyone would agree with that. That's definitely a question. Anyone on the call, if they have opinions, should voice them. My feeling is that if you're deploying a host OS and then trying to deploy something onto the card, you don't know what you're going to run into, and it's going to add additional support and testing complexity for ensuring that card and that firmware and the operating system all works as expected. So if it's actually a prime feature that we want to have on all these cards, then we're basically going to increase testing complexity. Whereas if we say we generally expect this to be the operating state to install an OS, then that's fine. And there might have to be a middle ground. Powered on, not necessarily running an OS, or it can run an OS, but there's no guarantee. And you'll want to reboot the host afterwards. That might actually be the simpler thing. And actually for DPU, provisioning machines with DPUs, we have logic that actually defers. We power the machine on and we ask it to boot into its BIOS menu instead of booting to a workload, so that the card can power on and boot. And then once the card is online and we, through the existing integrations, can verify that it's online, then we basically go, oh, boot to your normal workload now. I don't know how many people actually do that. I know some people have, at organizations on this call, have actually tested it and done it, but I'm just not sure if they have customers doing it. Anything else? Well, I hope this was helpful.
Really helpful. Thank you so much.
Well, if any of you have any additional questions, feel free to reach out. This is the thing I deal with day in, day out for the most part, is booting, deploying physical servers. So happy to try and answer questions or sanity check thoughts or ideas in this area. Lee, I do feel like we probably need the ability to say, I want to boot to a specific PXE device. I just have no good suggestions beyond BIOS settings. And actually, there might be something in the Redfish schema for that. Oh, and secure boot is a higher level object now, for the record, in the Redfish schema.
Okay,
it's-
so maybe we should try to come up with some suggestion to the forum to see how we are covering these requirements.
I think the question needs to be answered. How would vendors prefer operators boot the cards? And when I say how, I also mean by what model of connectivity. Because if it's an in-band network interface to the host OS, that's going to be different from it's a cable in the back of the card.
Right. So I think that finally we will need to support both because every vendor has its own preference here regarding connectivity.
Unfortunately, that is the same exact scenario we've run into in the Ironic project over the years. Well, I guess that's it, folks. Thank you. If you have any questions, feel free to reach out. I'm on Slack. I will not be around next week. I have another meeting, which unfortunately takes precedence.
Thanks, Julia. Thanks, everyone.
Thank you.
Bye.